Yes, sir.
Okay, so did you go through the one which I taught you last class, electric motor? Anybody went through or just blank? Anybody gone through? Harsh?
Yes, sir.
Asking you, did you go through the one which I taught you in last class?
Not really, sir. I had very much assignments to complete, so I will go through tomorrow.
You have to study, or daily you have to study. थोड़ा पढ़ना पड़ेगा.
Sir, generally I do, but I had to complete a lot of assignments from college, so I couldn't study.
असाइनमेंट को सेकेंडरी रखो यार. आपका असाइनमेंट होगा, असाइनमेंट में थोड़ी ना ये देख होता है, पढ़ो. एनीवेज, ठीक है. What about others? Others didn't study. I know, no use. Fine. So I'll go ahead. So in the last class, we studied about the construction of the electric motor. We studied how electric motor works, what exactly is electric motor, and what energy gets converted. So basically, what we studied. Harsh, Rishabh, what did you study? What is an electric motor definition? What is the definition of electric motor?
Hello, sir.
What is the definition of electric motor?
So a device which converts electrical energy to mechanical energy.
Okay. So can you give an example of electric motor which you see around? What is an example? एक एग्जाम्पल दो ना. कितना टाइम लग रहा है एग्जाम्पल देने के लिए?
Fan.
हाँ? Yes. Fan.
So ceiling fan.
Yes. Fan, grinder, okay, water pump, anything it can be. So we studied about the construction. We studied everything, almost everything. Now we will come to find out the torque. What is torque? What is torque? Torque is basically R cross F. When you say what is R cross F, I have this is a door. Door is connected with a hinge. Yes or no? What is torque? Torque is nothing but force in a rotational motion. Force in a rotational motion. So what you are doing, you are closing a door. If you are closing a door, door is rotated. Why? Because when you're opening a door and closing, door becomes like this. You open or close. Yes or no? So you are not applying a linear force. You are applying a force in a rotational motion. So torque is nothing but R cross F. When you say R cross F, it means RF sin theta. What is RF sin theta? What is R? R is the distance from here. Is the distance R and the force applied by you. Force applied by you. Understood? Clear? Yes, so sir. This concept we will study in the armature of the coil. That what is the actual torque? Because when it is rotating, when the armature is rotating, it is rotating no angular motion. Yes or no? Yes or no? When it is rotating, it is not a force, it's a torque which is coming into picture. So we have to find what is the calculation of the torque. Clear or not?
Yes, sir.
Is it clear? Harsh, clear?
Yes, sir.
Saurabh? Okay.
Yes, sir.
So this is the last class we studied about this. So basically, if I keep an armature, if you look from this side, it will look like this. It is basically like this. If you look from the front end, okay. But if I look from this side, this side, how will it look? Will it look like this? This is a magnetic field. Will it look like an arrow? Only one line? Yes or no? आप अगर ऊपर से देखोगे तो आपको ऐसे दिखेगा, एक रेक्टेंगल दिखेगा. बट आप अगर साइड से देखते हो तो ये कैसे दिखेगा? एक एरो दिखेगा ना, तो बस एक लाइन दिखेगा ना. जो लाइन घूम रहा है, चक्कर काट रहा है, yes or no? Am I correct?
Yes, sir.
Okay, so this we are going to discuss. And what is this? These are magnetic field. Clear or not? Clear. So forget about this one. We are going to consider this diagram. So let me redraw the diagram. So magnetic field ऐसा है. And this is the, what is this? Armature. Yes or no? Armature. Armature का कौन सा पार्ट है? ये वाला पार्ट, ये वाला पार्ट. आप इस तरफ से देख रहे हो, आप ऊपर से नहीं देख रहे हो. ऊपर से देखोगे तो आर्मेचर ऐसा दिखेगा. अगर साइड से देखोगे तो आपको ये बार दिखेगा. Is it clear? Bro, is it clear to you? So now what is happening?
Yes, sir.
This is the center of the armature. Armature is rotating like this. It is rotating like this. So basically what? This is the center and it is rotating. Yes or no? ऐसा आ रहा है. Am I correct? It is rotating in a circular motion. Yes or no? Understand? Huh?
Yes, I understood.
So now tell me, we studied about and we also calculated the field is this side. What is the force? Yes or no? And force here is? Yes or no?
Yes, sir.
We already calculated all this last class. How? You know current, which side is coming. So that means I told you in last class, agar I give an example, no, if I am pulling here and Rishabh is pulling here, both are pulling in a single line, it will not move. But let's say Rishabh is pulling like this and Dhruv is pulling like this, it will rotate. So this is a perfect example of a couple or a torque. This will lead to the rotation of the armature. Did you understand? Did you understand?
Yes, I understood.
So
Yes,
if I talk, the actual force which is being acting, it is making an angle theta. So if you see this, it is like a parallel line and a transversal, where this is theta and this is theta. Agree with me? And when these two angles are equal, that means what? What type of angle it is? Alternate interior angle. Yes or no? Yes or no?
yes, sir. Yes, sir.
Harsh, yes or no? So this is also theta. This is also theta.
Yes, sir.
But when I started, I told you that force is what force is acting in here. And what is the distance from here? This is the R, and in the same R, what is the force acting? But if you see here, this is the distance from here, because rotation is happening from here. Indoor rotation is happening from here. I am calculating from the point where rotation is happening. I am calculating the distance from here. But force is applying here. So we have to find the component of the force this side. Understood? Understood? Component of the force?
Yes, sir.
This side. So what will be the component
Yes.
of force this side? This will be what? F sine theta. Understood? F sine theta. Yes or no? How?
Yes, sir.
You know very well. Draw a perpendicular. Yes or no? Draw a perpendicular. So this is force. Let me draw like this. So look like this. If I'm taking this cutting and pasting here, theta is here. This is your F. Okay. And this is your this one. This is let me draw A, B, and C. So here is A, here is B, and here is C. We have to find out what is this value. Clear or not? So AB by BC is equal to sine theta. Yes or no? So what is BC? What is BC? Sorry,
AB
perpendicular.
sine theta.
No, wait. Perpendicular by hypotenuse. No. What is sine theta? Perpendicular by hypotenuse. We will do sine theta or cos theta. Wait, this one is no. This one is what? This is your F. Okay. F is the hypotenuse. So B by H. B by h equal to cos theta. So B is what? This is the base. This is the base. Then B equal to h cos theta, where f cos theta. This should be sin theta. How it is? Okay, I'll come to that. So currently just treat this as f sin theta. If this is f sin theta and the distance from this point, the total distance is w. Okay, so half of the w is what? W by 2? Yes or no? W by 2? Yes or no? So if I tell you what is the torque on this one, so can I say what is the formula of torque? Torque is R F sin theta. So what is R here? Distance? W by 2. So W by 2, and what is force? Force is F sin theta. Clear? Is it clear? Yes or no?
Yes, sir.
What else? Is it the only thing? Is this the only thing? No. Here also couple is there. No. Here also we have a what? Couple torque acting. So W double is the W by 2 F sin theta. So if you add, it will become what? W F sin theta. Clear? Yes.
Yes, sir.
So what did you study in the last class? What was F? What was F? What was F? बताओ F क्या था? ILB sin theta. Yes or no?
Yes, sir.
Yes or no? So force is ILB sin theta. So F sin theta already there. So I will replace it what? WILB sin theta. Here WILB sin theta. What is L? L is the length of what? What is the length? Length of the armature. Clear? Or the conductor. Understood? Understood, guys?
Yes,
Yes, sir.
So your formula, what will your formula will look like? Your formula, final formula will look like that your torque is nothing but NIAB sin theta. What is N? What is N? N is the number of turns. So that is normally there because if you have more turns, that will become more and more, current will get multiplied. Magnetic field will get multiplied. And because of that, you will have more output. Motor will become more. So if you see, if you break a motor, if you see, there will be copper turnings like this. Have you seen? Break a motor, small motor. You will see like this. More the turns, more the torque, more will be the output. What do you want basically from the motor? Motor should rotate faster. Yes or no? Yes or no? Yes or no? Correct or not, yeah? Tell me.
Yes, sir.
So now, what is A? A is the area of the coil. So what is the armature look like? Like this. This is the W. And what is this? This is the length. This is the length. So what will be the area? WL. That is equal to A. Understood? So WL became what? Area. What you are left with? IB sin theta. So what is your torque? If you have N turns, it will be NIAB sin theta. If N is 1, then it will become tau equal to AIB sin theta. Clear? Is it clear?
Yes, sir.
So if your
Yes.
armature is like this, perpendicular. So what is theta here? What is theta? Force is acting in this way, no? And force is acting in this way, no? So theta is 90. If theta is 90, what will be sin theta? 1. So what will be your torque? Torque becomes NIAB. That's all. Understood? Understood?
Yes, sir.
That means sin theta is maximum here. That means if the coil position is vertical, that time the torque is maximum. Why? Because sin theta is maximum. And when the sin theta is minimum? Here. Why? Because theta is what? What is theta?
0 degree, right?
Very good. Understood? Did you guys understand?
Yes,
Torque is maximum when the coil is vertical position, or you can say it is parallel to the magnetic field. Write down. You can write down a point. The torque on the armature is maximum. Torque on the armature is maximum when the coil is parallel to the magnetic field. Coil is parallel to the magnetic field. Torque and parallel to the magnetic field, and 0 when the coil is perpendicular to the magnetic field. Coil is perpendicular to the magnetic field. Clear?
Yes, sir.
Rishabh, clear? Any doubts? Raharsh, any doubts?
No, sir.
So next we will study about what is moving coil galvanometer. Have you heard about moving coil galvanometer? Anybody?
I've heard about galvanometer.
Sorry, sir.
Have you heard about moving coil galvanometer?
No, sir.
Okay.
No, sir.
Write down. A moving coil galvanometer, or nothing but MCG, or you can write the moving coil is an instrument used to determine the strength of the electric current in a conductor. Okay. So this is the actual function of a galvanometer. But what does MCG do? Earlier, whatever you wrote, it's for galvanometer. So what does MCG do? MCG is an instrument, okay, or a device. You can say it is an electromagnetic device, more appropriately. It is an electromagnetic device that can measure small values of current. Small values of current. Where is the small values of current? Current in the order of microamps, microampere or milliampere. What is microampere? 10 to the power
-6.
What is milliampere?
-3.
So you write like this, 10 microamperes. So this is not 10 microampere. This is 1 microampere. 10 to the -6 is 1 ampere. So 1 microampere is what? 10 to the power -6 microamps. Sorry, amps. So 10 microamps matlab 10 to the power 5 amps. Okay. So when I say 1 milliamp is 10 to the power -3 ampere. So if I say 10 milliampere, it is 10 to the power -2 ampere. Clear? Clear? 10 multiply ho jayega. Understood? So what does it
Yes,
contain?
sir.
What does it contain? So we will study about what does the MCJ looks like, what is the principle of MCJ. Okay. So we will first understand how first we'll draw the diagram of a MCJ. Okay. Let me draw the diagram of a MCJ. So MCJ, we have one north pole. Always magnets are important. What does the requirement of magnet? To provide a magnetic field. Okay. So you have again some kind of hanging here. So that will look like a mirror. इधर थोड़ा सा एक mirror है. ये एक mirror है. Mirror. This is called suspension. Suspension मतलब थोड़ा सा कुछ spring है. तो ये ऊपर नीचे होता रहेगा. Suspension. ठीक है. And there is a moving coil here. There is a coil here. And coil here. There is a lower suspension here. ठीक है. And this is iron core. Core iron बोलते हैं. Turns रहता है. Core iron. Iron core. ठीक है. Which is stationary. This is stationary. And there is a moving coil. ये coil move करे. Moving coil. ठीक है. And these are magnets. Permanent magnets. Permanent magnets. Clear? Clear?
Yes, sir.
So this is the construction. So if you want to write, you can write down. It consists of a rectangular coil of a large number of turns. Okay, the turns, बहुत सारा turns है. Okay, of thinly insulated copper wires wound over a light metallic frame. This is a metallic frame. ठीक है, उसके ऊपर ऐसे बहुत सारे turns है. Turns. The coil is suspended between the pole pieces of horseshoe magnet by a fine phosphor bronze tip, and the lower end of the coil is connected to a some suspension. Okay. Soft iron cylinder is placed symmetrically inside the coil. The hemispherical magnetic, these are hemisphere. Yeah, hemisphere. Basically, these poles are not like this. It's actually like this. These are actually like this. It's called hemisphere. Hemisphere means half of circle. Yes or no? The poles, that magnets are of the shape of like this. North pole. क्यों? उसका एक रीजन है, मैं बताऊंगा नेक्स्ट क्लास में. क्यों ऐसे क्यों बनाते हैं? Why can't we put like this? Why can't we put like this? Why hemisphere? ठीक है? And there is a small mirror attached to the suspension wire with a lamp and a scale arrangement to measure the reduction. Clear? Till now clear or not? So what is the principle? What exactly principle? The principle, write down a definition. Torque acts on a current carrying coil. Write down. Torque acting on a current carrying coil suspended in the uniform magnetic field. Suspended on the uniform magnetic field.
Suspended on?
Suspended in the uniform magnetic field. Due to this, the coil rotates. Due to this, the coil rotates. Hence, the deflection in the coil of a moving coil galvanometer, deflection of a moving coil galvanometer is directly proportional to the current flowing in the coil. ठीक है? ठीक है? तो मुझे बताओ, in the when you studied the torque, before that we studied found the formula NIAB sin theta. What does it say? Can you tell me the torque, more the torque, more the rotation? Yes or no? More the torque, more the rotation. But what does torque depend on? Torque will depend on what? N, I, A, B. A means the area of the coil. So is the area of the coil changing or it is constant? It is constant. Yes or no? Are you changing? No, it is constant. Turns, N is also constant. B is also constant because you are using permanent magnet. You are not using electromagnet. When you use electromagnet, you can change the magnetic intensity or the magnetic field. Give more current, you'll get more stronger magnet. This is a permanent magnet. Permanent magnet do not have, they have fixed magnetic field. So out of 1, 2, 3, 4, out of four what do you call this? Variables or 4 items, 3 items are fixed. So what is the item? What it can change? That is what? Current. That means your torque is directly proportional to the current. More the current, more the current, more the torque, more the torque, more is the rotation. More the rotation, more the deflection. Is it clear? Is it clear?
Yes, sir.
So what is the actual principle of a what is the actual principle of MCG? MCG actual principle है कुछ नहीं है, छोटा सा करंट भी रहेगा, that will create a deflection and you will be able to measure the small amounts of current in the order of microamps and milliamps. Normal galvanometer, okay, cannot measure. Normal galvanometer में microamps नहीं measure कर सकते, milliamps से measure कर सकते. अब अगर galvanometer देखोगे, it will look like this, something like this. It will look something like this. Have you seen galvanometer? If you go to your college, they will have a like this. There will be an something like this, and some values will be here. This will rotate. The ऊपर नीचे होता रहेगा. अगर ज्यादा करंट है तो ये इधर आएगा, ठीक है. कम करंट है मतलब यहाँ पर 0 रहता है. अगर आप एक डायरेक्शन में करंट दिया तो इधर जाएगा, दूसरे डायरेक्शन में करंट दिया तो इधर जाएगा, बीच में ये 0 रहता है. ये बट इसका जो you can measure only or up to milliamps only. But if you want to measure microamps or below, then you have to use MCG, moving coil galvanometer. Why? What is moving coil? Actually, this coil, what we studied in the motor, is actually rotating, and this because of this rotation, you are getting able to find out the deflection. You are able to find out the change. How? Because you know that your torque depends on N, I, A, and B. And you cannot change N. N is fixed. Area of the coil is fixed. You are not changing the area of the coil. You are not changing magnetic field because magnetic field है permanent magnet. So what is the quantity which is changing? That is I. So थोड़ा सा अब I को थोड़ा सा भी change करोगे, torque change होगा, torque change होगा, deflection होगा, deflection होगा तो पता चल जाएगा current है कि नहीं. Is it clear to all of you? Guys, clear or not? I can't hear anybody. Is it clear or not?
Yes, sir.
Once clear?
Yes, sir. Clear.
So, एक बोलते हैं sensitivity. बोलते हैं हम लोग sensitivity. ये पढ़ लो. इसका notes मैं आपको बाद में दूंगा अच्छे से बना के. ठीक है. हम बोलते हैं deflection को बोलते हैं phi. कितना deflect किया उसको बोलते हैं phi. ठीक है. तो and एक restoring torque मतलब आप कैसे होता है मैं बताता हूँ. अब अगर आप मैं मुझे बताओ, आप अगर एक take a rubber band, you tie a small stick, छोटा सा ये करके इसको रोटेट करो. रोटेट करोगे, छोड़ दोगे, ये फिर से रोटेट करेगा कि नहीं आगे? इलास्टिक के लिए रबर बैंड में टाई करके you rotate it this side and then you leave it, immediately it will rotate the other side or not because of the elasticity. Yes or no? So the deflection in the moving coil, coil galvanometer is given by the phi. That is, phi is a deflection. Understood? And K is the constant. That is called torsional constant. TORSIONAL. Constant. क्यों? क्योंकि मैंने बताया, क्योंकि एक स्प्रिंग है ना, दो स्प्रिंग रहता है ना, मैंने बताया ना स्टार्टिंग में. यहाँ पर एक सस्पेंशन रहता है और यहाँ भी एक सस्पेंशन रहता है. जब ये रोटेट करता है, जितना ज्यादा रोटेट करेगा उतना ज्यादा ये क्या होगा, पीछे रोटेट करेगा. क्यों? स्प्रिंग है. ये मोटर नहीं है कि घूमेगा, कंटिन्यूअसली घूमेगा. ये फ्री नहीं है. ये यहाँ पर एक स्प्रिंग लगा हुआ है. अगर आप एक डायरेक्शन में इसको रोटेट करोगे, ये दूसरे डायरेक्शन में फिर से रोटेट करेगा, बिकॉज ऑफ द स्प्रिंग, बिकॉज ऑफ द स्प्रिंग, एक्शन ऑफ द स्प्रिंग. सो दिस के इज कॉल्ड द टॉर्शनल कांस्टेंट. ये स्प्रिंग के लिए कांस्टेंट है. तो योर के फाई इज इक्वल टू NIAB. And if you want to find out the deflection, the formula for deflection is phi equal to NAB by K into I. Clear? Is it clear? That
Yes,
means your phi will depend on what? Will depend only on I. More the, मतलब वही चीज है ना, more the I, more the torque, more the deflection. Less the current, less the torque, less the deflection. So your phi is indirectly responsible for I. Why it is written in a bracket? Because all these are constant. You cannot change this. Spring you are not changing, N you are not changing, area remains same, B remains same. So if you write phi is nothing but something like, you can write as Ti. What is Ti? T is the constant that you can take anything. T is nothing but this one. And I is the one which is changing. The current is only changing. Did you understand, guys?
Yes, sir.
Yes, sir.
Harsh understood? Harsh, I can't hear you. Any doubts till now?
No, sir.
Swarup, any doubts?
No, sir.
Good. So next we'll come to magnetic moment. What is magnetic moment? Anybody? Any idea? What is magnetic moment? Any idea what is magnetic moment, guys? Write down the definition of magnetic moment, then we'll study. Magnetic moment is the magnetic strength. Magnetic moment is the magnetic strength and orientation of a magnet or other object that produces magnetic field. Rejoin karo, please rejoin the meeting.